Okay, so here is another activity that we did with the kids, and this was called the surveyor's wheel. And we had one that we had used when we were designing our 3D models of our houses and so forth. And so here's what I gave them. I gave them the circumference that I wanted their wheel to measure. Okay, so I gave them their circumference I wanted their wheel to measure. They had to figure out how they wanted to design and make their wheel so that it actually turned. And you can see this kid here use some sticks and some of the meter sticks here. These guys even put tape around theirs to try to hold it together. Here's a little bitty one here. So I did a little bit of everything. I did not do the traditional 1 meter or 1 yard. So everything was either a half a meter or 3/4 of a meter or 1.5 meters or 2 meters or so forth. As you can see, this one I'm guessing was probably closer to the 1.5 meters or so. So again, a very fun activity on that. These use PVC pipes. So I did have a lot of different stick type things that they could use on there. Here's a Desmos activity, just a real quick one. Again, they were to just use, they were just to use lines. We were doing positive, negative lines. So again, they have to draw it out, and then they have to write the equations for the lines. Okay, and again, doing domain and range. And I think this really emphasizes domain and range. Okay, this one I think was for I think this was for Algebra 1. This one was for more of the Algebra 2 kids. So then, of course, we have lines and we have circles and we have our sine waves and we have parabolas and so forth. So I usually have my kids do this about every year. I just add to how many different types of graphs that they have to use. There's some more. Okay. Again, this is my transformation activity that I have the kids do. This one they do by hand, but you could definitely also use a GeoGebra or a different app to do it. But they do have to draw their original, and then again, they do have to put all their points down for me and write them out. So they must do 3 rotations, 3 reflections. They have to do a size change and a scale change on that and give me all and then put their originals on there. So it's a pretty cool, again, little activity that they do. And there's a whole bunch of different ones. So some of your kids who are not as math oriented maybe, but when they start doing things like this, they really tend to come alive. This was just a fun thing. It wasn't even really anything serious. We were having some downtime, and it was as some were finishing and others were not, and they just had to design me a picture with triangles. That's all it was. Everything had to be triangles, and they did have to use all the different types of triangles. Of course, it's city design. This is in geometry. You've probably seen this one before, where we're talking parallel lines, perpendicular lines, different, corresponding corresponding alternate interior, alternate exterior, and so forth. And everything had to be placed in the correct spot. Again, it's just making what they're doing not just 100% textbook oriented, but trying to think out of the box and make it fun and exciting for the kids. This is a blast for the kids. Again, it's with slope, linear equations, scatter plots, and then the extrapolation that I love, Barbie Bungee. And you give the kids, usually I'll give them maybe 10 rubber bands at most, maybe not even that. Give them the Barbie, and then they have to be able to figure out a way to determine how many rubber bands it takes for Barbie to bungee without killing herself. And you can see here on this one, especially if you zoom in, how close she was. Her hair was touching, but she did not crash on that. And then, of course, we just find a high spot on that. And so, again, the goal is that they'll start realizing that, okay, I'm going to do points. One rubber band, she falls this far. 2 rubber bands, she falls this far. 3 rubber bands, and so forth. And then continue on there. I think this one has actually a video that goes along with it, which you could also watch on your own. The other thing is I do record in slow motion so they can see what's happening. So obviously he did not make it. And again, the goal is to see who can get the closest on their Barbie without without killing somebody, or Barbie in this case, on there. So okay, another one, and this is a one I do a lot just with freshmen, again, collecting data, line of best fit. I do it what's called the Da Vinci Man golden ratio. We do body parts, so they have to measure, of course, their arm length and their height. We do their foot length and the length of their from elbow to wrist. I can't remember what all there is. Anyway, they have several different ones that they have to do. And again, we just do scatter plots, find the line of best fit, and see if in fact it does fit the ratio as suggested by the Da Vinci Man. Let's see, this is a geometry project. Again, vanishing point, in which they had to, again, draw a picture. And they actually did this on fairly large paper, and then I actually took pictures of it. So this one in particular they took on big white roll paper, and then we put it on the ceiling, and it looked really cool. Again, this one is an example of down our hallway, and then of course from up above type of things. And of course their testellations. They always love that. This was a cool one to do when you're talking about orthocenter, centroids, and circumcenter. And I had them make a pennant for our team, or this one, and we did it for our team this year. Some years I just let them do it for any team that they want. And the key is that it does have to be your triangle, and they have to have the circle inside. It's kind of the two that I require. Of course, just I have them do a slope in real life. They can take any pictures and then print them and use their drawing tool to actually write on them. Oh, these are some different things for more of the physics class. So I think that's it. Oh, I talked about already the M&M activity.